I'm recording. Here we
Yes.
go. So the first part we'll cover today is station operation and setup, mostly about the controls on a typical HF radio. Uh, so one of the, uh, not sure what the order of these is, but one of them that is on most uh, HF base station type radios is called a notch filter. Its purpose is to actually blank out or create a notch in the the passband that you're receiving, so that you can try to eliminate an interfering signal. If you're listening to a particular frequency and there's another transmission that's close by, uh, you can use the notch filter to move over and essentially eliminate that frequency out of what you're listening to. Another one, I'm not sure that all HF radios have an IF shift. They usually have some form. A lot of the more modern ones, particularly the SCR type radios, call it passband tuning. And they actually will have two controls that will let you move your IF filter left or right so that you can pair them up or offset them. In essence, it allows you to move where your IF filter is relative to the signal. Once again, the purpose is so that you can try to eliminate some interference if you got a close by station. Uh, this is a ICOM 7300. It's probably one of the most popular sort of starting HF radios. And this is the notch filter we talked about. And you just press that button and uh, it tries to notch out that frequency.
So what's the definition of notch when you say notch out that frequency? Is that tune in?
No,
No.
eliminate. So if you look at
Eliminate.
this one, okay, you see the waterfall down here,
Yes.
okay, and when we did the notch filter, we blanked out this section of the spectrum. So whatever that's any signals at 7.10 megahertz, you're not going to hear.
Okay, so basically it gives you an opening.
Yes,
Use. To use. Okay.
this it creates a notch in the passband.
Understand.
And that's to stop, like if you have a bad noise area and you want to notch it out, or is that for you to actually try to use it?
No, it's try to eliminate the interference.
Okay, just wanted to make sure because
Yeah, I thought you meant so that you could use it. Like it blanks it out so that it opens it for you to
No,
use.
no, no. It's so you don't hear anything there.
Okay, and what would be the purpose of that what would be the purpose of that?
Well, if you're
I mean, if you can't, if there's interference there, you can't utilize that area. So why would you bother blanking it out if it's not going to benefit your?
because you're hearing it and it's causing interference.
it's like
Okay.
if somebody was nearby. Is that what you're talking about? If
Right.
I had, so
You're
somebody
hearing
nearby.
you're hearing another signal. It's like somebody else talking in your ear while you're trying to communicate.
Okay. So by doing that, it'll eliminate them, but you can stay where you are.
Correct.
Okay, I understand.
I mentioned the IF shift, or like on a radio like this, most of the SCRs, I believe, work this way, and they have uh, passband tuning where it lets you shift the uh, IF filter around left or right, make it wider, make it narrower, so that you can try to eliminate interference. That's what most of these controls are for, is so that you can try to maximize the signal you're trying to listen to by getting rid of the stuff you don't want to listen to.
Hey, Bob,
Uh-huh.
I hate to do this, but IF, what is IF?
Intermediate frequency.
Okie dokie.
Yeah, that's one of the bad things about talking about these controls before we've actually talked about how a radio works.
Right. Okay, but I got the words. And the other word I wanted to ask about was passband.
Okay. The passband is the band of frequencies that you're listening to. Typically, if you're doing single sideband, you're going to be listening to a 3 kilohertz wide
Uh,
passband, because most of the voice, uh, intelligible voice, is going to be within like 200 to 3,000 hertz.
Good, thank you.
That was something that the uh, telephone company learned a long time ago. Um, and that's why regular landline phones actually were constrained to 3 kilohertz, because you didn't need the extra frequencies. It didn't really make your sound any more intelligible, and it costs more money to transmit that wider bandwidth. And it's the same thing here in radio. You want to minimize the bandwidth because it helps eliminate noise, the narrower the bandwidth is, and help maximize your signal. So that's one of the reasons why we use single sideband as opposed to regular AM, because regular AM would be 6 kilohertz wide. Single sideband is only 3. This is a little diagram showing kind of how the passband tuning or IF shifting works. And you can move the red and the blue passbands back and forth. So when they're overlapped like this, then you get a narrower passband, and it can also be shifted left or right. So if you had an interfering signal, say over here, okay, then I've narrowed it and shifted it a little bit, so I'm no longer picking up that interference that's outside the new passband. Hopefully this will make more sense when we talk about how radios work.
I was going to say, is that kind of like a tuner? I mean, is that the idea, or you're just trying to dial into the exact?
Well, when you tune, okay, you're tuning in the center typically of your passband, your IF passband.
Mhm.
So if there's a station that's closer than, well, excuse me, for single sideband, you'd tune it to where the carrier should be, which would be the bottom or the top of the signal, depending on whether it's upper or lower sideband. So if you had another interference that was within that 3 kilohertz, then by shifting your passband relative to where you're tuned, you could eliminate it, possibly.
Okay.
And you can also narrow it, which makes the voice signal a little less intelligible. But if it's a trade-off. If you get rid of the interference, then you might still be able to understand.
Bob, it makes me think about if you have a camera with a lens that you can make longer or shorter focus.
Uh-huh.
a zoom lens,
Right.
and you can focus it. So you might be aiming at a certain area just by default, and then you say, well, I want to, this is an analogy, right? So you pick the zoom that gets you to the right place. So you're focusing on it, and then you focus on it in order to make it sharper.
Well,
How
not
does that hold up?
exactly, but
No?
that is one of the things you see on a number of SDR type radios where they'll display uh, a spectrum, which would be the white on the top here, and the waterfall below it, which is basically showing the history of the spectrum.
Mm-hmm.
Okay. In a lot of these radios, they have what's called a zoom. Okay. And you may be looking at um, that spectrum that could be a couple hundred kilohertz wide. Okay. And you're trying to find a signal that's only 3 kilohertz down there. You can zoom in to that spectrum. Okay. And basically spread it and get it down to maybe, 10 or 20 kilohertz for the whole spectrum. And it makes the signal appear much wider. But that's a little bit different than what we were talking about as far as the passband.
It's almost like having a picture and blowing it up, and then you get to see all the pixels.
Exactly. One of the other controls is a lot of times you'll have what's called a preamplifier. So if you're looking at weak signals, you can push the preamplifier button, and it might have 2 stages where you'd push it twice. So it might give you a 10 dB gain, and the second time a 20 dB gain, something like that. Also, if you keep toggling it, typically it will bring in an attenuator, which will reduce the signal by 10 or 20 dB. Because sometimes, particularly on the lower bands, with all the noise, you're better off attenuating uh, the signal than you are trying to amplify it. And that's just something that, you learn how to use that just in operating it, depending on how much noise and stuff there is or how weak the signal is. It's like most things, there's a trade-off. Having the highest gain is not always the best. And if you've got a very strong signal, you'll definitely want to engage the attenuator so that you don't overload the front end of the radio, which causes uh, distortion on the signal. Another control, again, this is to do with interference. It's called a noise blanker. That's the NB, you see. And it's specifically there to try to remove noise sources like car ignition, kind of man-made things like welding machines, stuff that has high impulses. And again, these are things you find in a software-defined radio where it's a computer that's doing a lot of the signal processing, and it will try to find and eliminate those pulses. So whenever it sees the pulse, it will reduce the gain, kind of like what the notch filter does, but this is more dynamic. It only reduces it when it senses the noise pulse. So it tries to just blank out the specific noise pulse. You also have a noise reducer. That was the NR button next to it. And a lot of times it'll have multiple levels of noise reduction. And it uses different types of noise reduction techniques to eliminate background noise so that you can kind of clarify the signal. And actually, they tend to work fairly well. One of the problems with them, though, is if you do CW, they can kind of think CW is noise and try to reduce your CW signal. And speaking of CW, most of these radios have a built-in Morse code keyer, or think of it as a CW generator, where if you use a paddle as opposed to a straight key, okay, it will automatically send the dots and the dashes depending on whether you push the left or right paddle with the proper spacing and length. So all you have to do is learn how to time when to, let go of the left and push the right, and just the timing in between those. Also, a lot of these keyers will allow you to store some pre-canned CW messages. For instance, on the 7300, it lets you do that, and you have these 8 kind of memories, and you can program those with essentially whatever you want, Morse code sequences. A lot of people will do that and use them in contests, and can almost carry on a conversation in a contest because you're not really communicating anything other than your location and your signal report and a QSL. And so if you have all those things programmed in there, you can just carry on a communication by pressing the appropriate button and not even use your Morse code key. Another one that's very important is your sideband selection. In this case, it's a software button that's on the display. And if you tap it, it will toggle between different modes and lets you select between lower sideband or upper sideband. It may bring up a menu where you have more options than that, and you can select AM, FM, PSK, RTTY, things like that. Depends on the radio and what modes it supports. Oh, and we talked about before passband filter. Usually you'll have a software button like this, which lets you select different pre-programmed filters. So filter 1 in this case is like 3 kilohertz wide. If you tapped it again, you go to filter 2, which is probably about a kilohertz, forgot exactly. And filter 3 would be basically for CW, and it'd be down around 400 or 500 hertz. And one of the things here, if you're doing CW, you can select lower sideband to try to eliminate interference. Because remember, CW is generating both sidebands. It's essentially doing your carrier as opposed to single sideband, which doesn't have the carrier. You can't do this with single sideband because if you're transmitting upper sideband and you try to receive in lower sideband, your voice frequency is totally inverted, so it's not going to be intelligible. Likewise, you can't do upper if they're transmitting lower. And that's why the protocol of above 10 megahertz, you normally use upper sideband, and below you use lower sideband. Split mode is a case where you have a radio that has what we call dual VFOs, or variable frequency oscillators. That's what you use to tune the signal. And in split mode, you can be transmitting on one frequency and receiving on a different frequency. And sometimes that's useful, as long as you both know what the split is. In other words, if you're talking to somebody on 7073, which you wouldn't do because that's an FT8, but or just below FT8, it's not voice. And you were listening on a different frequency, you wouldn't be able to communicate unless the other person knew what frequency you were on.
Bob, sorry to have interrupted you, but a lot of the repeaters all have a split mode type of thing going on where you receive on one and transmit on another. But you're saying that you can also do that just between you and I if we were communicating, we could set that up,
Correct.
right?
Correct.
Okay. It doesn't have to be line of sight. It doesn't have to be going through a repeater or anything. It's
Right.
just,
The
okay.
repeater does it automatically, and that's one of the things you have to set up, which is the offset,
Hmm.
which can be plus or minus either 600 kilohertz or 5 megahertz, depending on whether you're VHF or UHF. Unless you're talking to a satellite, where the satellite does a similar thing, except you can transmit on VHF and receive on UHF and vice versa. So it's not just a frequency shift, it's a whole band shift in the case of a satellite.
Okay. Thank you.
Bob, in
Uh-huh.
in this context here, if I use this split button,
Uh-huh.
I'm I'm only using it to talk to someone else directly, back and forth.
Yes. But that's
Okay.
what you're doing either way. With the HF
Oh,
radio, you're basically doing, a point to point, unless it's a
right.
net.
Right. So let's just keep it really. So if I'm calling you, not a repeater,
Uh-huh.
because that's a different thing. So if I call you, I'm talking to you directly,
Right.
then I could say, well, this is a little fuzzy. Let's try this split thing, and we'll both transmit on this and receive on that. Well, actually, they'd do the opposite, wouldn't they? They'd be doing the opposite.
Right.
Right.
But yes,
The
absolutely.
way the repeater does, but in this setting, this button is only for me talking to you, no repeater involved, no, nothing else, just me talking to you.
Right.
Right.
Thank you so much for that clarification.
Okay, and I mentioned dual VFO, uh, which you kind of need that to do split. Uh, but it also allows you just to listen to a second frequency. So you can be communicating on the primary, usually they'll call that main, and the other one is usually called a sub. So you can have the sub set up to even on a different band, a different frequency, and you can monitor signals on that other uh, frequency or band. Okay. Automatic level control is a function in the radio that tries to limit the signal level that's going into your final amplifier stage. The purpose is if you don't want to overdrive your power amplifier because it will start creating third and fifth harmonics. We call them spurs. And according to the FCC, your third harmonic should be at least 43 dB below the carrier. So if you start overloading, you'll start generating those third and fifth harmonics to where they're exceeding that level. So you're kind of violating FCC regulations. That's one of the reasons why you won't do it. It also is producing a lot of distortion in the signal. So somebody listening to your signal is going to get a very distorted signal. It's very important if you're doing some of the digital modes, probably more important, because it seems to affect the digital modes even more as far as distorting the digital signal. In the case of audio, typically and you can bring up your ALC as a meter display. It's usually just like a bar graph. And you usually want to keep that so it's down in the 20, 30% or less range. When you get up to like 50%, you're going to start to get the clipping and distortion. If you're doing a digital mode like FT8, you want to adjust your gain and gain from the computer, speaker output from the computer going to the radio to a level where you almost don't see the ALC move at all. And there's what it looks like on the 7300. And they have the red bar here, kind of showing you the voice range. You want to stay, you don't want to exceed that. And like I said, for digital, you want it to be off. And this will light up with white bars as you have an ALC signal. The ALC is also usually connect the output from your radio. There's an ALC connection that will go to a external power amplifier if you have it. And it serves the same purpose, okay, to try to limit the power going into your external amplifier. Speaking of power amplifiers, if you have one, like I mentioned, it has an ALC input, so that's one of the reasons why you want to adjust your ALC. In the case of the power amplifier, particularly a solid state one, overdriving it not only can cause unwanted harmonics and distortion, but you could also tend to burn up your output power transistors. Solid state RF amplifiers are much more sensitive to high SWR and things like this than an old tube type. The load or coupling control is one of the controls you'll see on a power amplifier where you try to adjust it. In this case, they're talking about a tube type where you try to adjust for maximum power output and also minimize the amount of plate current going to the tube. And you usually have three controls on, well, two controls, a load and a plate. They're called on most of the old tube types. And you have to kind of play with both of those to try to minimize the plate current and maximize the output power. That's one of the things you don't get to do on the solid state power amplifiers. Here's a typical, this happened to be a VHF one. And there's your plate. And in this case, they call it input, would also be called load. And these meters over here, which you're monitoring your output power and your plate and grid currents.
Why do they call it plate?
Well, because it's a vacuum tube, and a vacuum tube device has 3 or more elements, depending on whether it's a triode, a pentode, a tetrode, or whatever. So you have a cathode. Well, okay. The most basic vacuum tube is a diode. You'll have a cathode and a plate, analogous to a solid state diode where you have a cathode and an anode. You could call the plate the anode. And current travels from the cathode, the electrons, to the plate. That basically gives you a rectifier. It will only pass current in one direction, like a solid state diode does. And we haven't talked about those yet, so I don't want to confuse you too much yet.
Sorry. But why do they call it a plate? Is it shaped like a plate?
Uh, Kinda. I think
Okay, we just
it
some
really
things we
was in the very original ones. Uh, when you make it a controllable device, you add what's called a control grid. And it's some wires that are in between the plate and the cathode. And depending on the voltage that you put on that control grid, either positive or negative, it can affect or control the flow between the cathode and the plate, which allows you to use that as an amplifier or a switch. Because now I have a voltage I can control that will control the current going through that tube. Then they start adding additional grids to reduce capacitance and do other things to improve the efficiency, but essentially all you need is those 3 to have a control device.
that's probably enough for now.
Good.
Thank you.
Another thing that's in the radio is kind of a time delay circuit. And its purpose is when you switch from receive to transmit on your transceiver, both the receiver and the transmitter portion are connected to the same antenna. And they're connected through what we call a TR, transmit receive switch, which in a lot of cases is just a relay, or in more expensive and sophisticated ones, it's pin diodes, which can be a solid state switch, which will switch much, much faster, which lets you do those break-in modes we talked about on CW, where you can listen in between the dots and dashes, because what you're doing is switching between transmit and receive. So you have to do that pretty quick. If it's just the relay, you have to give it time for that relay to actually switch from receive to transmit before you actually enable the transmitter. Otherwise, you'd be feeding your 100 watts back into the receiver one time, before you send it off for repair. Okay. A lot of these radios will have what's called a built-in antenna tuner. They call it a tuner. It doesn't tune anything. It's a matching device. And it's there to try to match the output of your transmitter to your antenna. Most transmitters are designed to have approximately a 50 ohm output, 50 ohm impedance on the output. You usually try to get an antenna with a 50 ohm input impedance. That's not always possible, depending on the antenna. In most cases, like a simple half-wave dipole is going to be about 75 ohms. An end-fed wire antenna may be 2,000 or 3,000 ohms. An offset fed is going to be 200 or 300 ohms. So all these different antennas have all different impedances. Very few wind up with 50. So you need some way to match the impedance between your transmitter and the antenna. The purpose is you want to transmit the maximum amount of power that you can into the antenna. If you have a mismatch, you're going to get a big reflection, and a large portion of your signal is going to just be reflected back and not radiated out of the antenna. So that's the whole purpose of a matching device, is to try to make your radio think it's talking to a 50 ohm antenna, and make your antenna think it's being sent a signal from whatever its impedance is. The built-in tuners can be automatic or manual. Like in the case of the 7300, you just press the tuner button and it will go through and do a lot of trial and error of switching inductors and capacitors until it finds the lowest SWR that it's able to do. Most of them can match up to an SWR of 3 to 1. If you've got a mismatch higher than that, you normally have to use an external tuner that gives you a bigger range. But if you got a mismatch like 10 to 1, you might want to be looking at fixing your antenna. This is an old MFJ external antenna tuner. It's an analog type. So you actually switch in different inductances with this middle knob, and these other two are controlling variable capacitors that are on the input and output. And we call that either a pi or a T configuration matching network. You don't need to know that for now. And this one also has a built-in SWR meter, and this is what we call a dual needle type, where one of these analog meters is showing you forward power. This is reflected, and the other one is showing you forward. So it's showing you forward and reflected. Ideally, if you were sending out 100 watts, you would want the needle up here at 100 on forward, and you would want your reflected needle down here about 0. You'll very seldom see that. So you'll have both of these needles moving. And these little red lines are pre-calculated SWRs. So where the two needles cross on one of those red lines, it will tell you what the approximate SWR is. Where some of the digital meters will just display your SWR as a number, and it may also display your forward and reflected power. Okay, any questions on all of that?
Just
Before
a lot.
Well, we'll try to explain them as we go through. So,
This is good.
what's the purpose of a notch filter?
It's oh,
Bravo.
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 Very good.
Yeah. One down.
Reduce interference is the big one, right? Reduce interference.
Yes.
What is the benefit of using the opposite or reverse sideband when receiving CW?
I'm guessing
Charlie.
Charlie.
Charlie, yeah.
Charlie, these are all easy.
That's it for
Sorry
you.
for you.
How does a noise blanker work?
Charlie.
Oh,
Bravo. It's a bravo.
Is it?
Uh-oh.
Going with
well, I thought a blanker was the
Charlie.
pulses.
Hang
'Cause
on
it-
a
Oh,
second.
oh, yes, Charlie. I read it redirecting. Okay, yes, reducing.
Right.
Oh, wait a
Okay.
minute.
The,
Go
the
back.
key word to that was one was reducing and one was redirecting.
Right.
Oh, thank you so much. Never
Yeah,
mind.
I didn't catch that right away either.
Always read the answers twice.
Yeah,
Because you can't just read noise pulse and know you've got the answer.
Right.
and that's what I did.
Yeah, me too.
What's the effect on plate current of the correct setting of a vacuum tube RF power amplifier's tune control?
not a clue.
Bravo. Bravo.
Right. You want to dip it. If you have too much plate current, the plates on the vacuum tube will start turning kind of a cherry red for a while.
Well, I didn't know what exactly we would look for. That was the thing. I mean, I remembered us talking about plates and cathodes and whatnot, but I didn't remember that particular thing about it or even us talking about it.
I think I talked about
Sorry.
it.
Somebody knew the answer, not me, but somebody did. So,
Okay. Well, now you'll
Mhm.
remember it.
Mhm.
You may not get that question.
Uh-huh.
You'll only get one of these. Okay, what's the automatic level control used with an RF power amp? Why is it used with an RF power amplifier?
Charlie.
Charlie, yeah. Let's try.
What's the purpose of an antenna tuner? And I hate that word. Remember what I said? It's
Alpha.
Yeah, alpha, you're gonna reduce the S.
Oh, it's not the reduce.
Oh,
It's something from the transmitter to.
It's about matching things, not tuning things. It
right.
doesn't affect the antenna at all. I know that much.
Yeah.
So
But
that
I
we
What
don't see it
and
in
what's the
Charlie.
purpose of matching? Why do you want
Oh,
to match?
bravo.
you have an
Bravo.
equal, yeah,
Bravo.
you have an equal power dissipation in the P line to the antenna.
Keep thinking.
Should we say delta? Oh, you go for delta.
No, I'm still going with Charlie.
I like bravo best.
Let's go with Charlie.
All right.
Increased power
Okay.
transfer.
Let's talk about alpha. It does not change the SWR in the feed line to the antenna.
Okay.
Between the matching device or the tuner and the antenna, nothing has changed as far as SWR.
Okay.
It does not reduce power dissipation in the feed line. That's strictly a function of the amount of loss in that particular coax, which is a function of frequency. So some coaxes have fairly high loss at high frequencies, particularly the smaller ones. So that's kind of a fix. It depends on the feed line itself. Has really nothing to do with, or very little to do with, your matching network.
So can I ask you a quick question?
Okay.
Increasing the power transfer from the transmitter to the feed line. So that basically, if I read this correctly, the tuner is increasing the power to the feed line.
Yes.
And then it will, like you were talking about the antenna ohms and stuff, it will, but is that a different thing, or is that part of the tuner where it tries to connect to the proper
Basically, the tuner is trying to protect your transmitter.
Okay, so it is trying to match that so that you don't over.
Right.
Okay, that's
So
And I thought I had a chart in there. Maybe it's in another section. I don't know why. Which shows this little graph showing power transfer. When you have a match on each end and you don't have a match on each end. And let's say you have a perfect 50 ohm antenna connected to your perfect 50 ohm transmitter. You're only going to transmit, and you're transmitting 100 watts. You're really only transferring 50 watts to the antenna.
because of the 50 ohms being
Because
impedance.
you're gonna lose half of it in the transmitter and get the other half to the antenna to radiate.
So it equalizes itself out so that you don't
Right.
over. Yeah. Okay, I got
And
you.
if they're not matching, you get even less. You'll dissipate either more or less. Well, in most cases, less at the antenna and more at the transmitter. Okay, what happens as a receiver's noise reduction control, that's the NR button, is increased?
Alpha. Distorted.
I thought it was just, was it distorted or unstable? I guess distorted.
Well, remember, are you reading all the answers?
TW signals may become severely. Receivers noise reduction.
Well, the noise reducer is in charge of making the signal more
Yeah.
readable.
Right. So that would be severely, that would bring.
And I did mention
Maybe
this.
you said it would make things more readable. That's what you said. It was right on the slide. Reduces noise, makes the signal more readable.
But I don't see that answer.
I don't either.
Well, then that must not be it.
So I would say Charlie, because it would mess up your. Yeah, I think you said it would help with the audio, but not with the CW, like with your voice, but not the CW.
Right. Because it doesn't know that that's voice. It thinks it's noise.
Yeah, you did say that.
Pretty sneaky, if you ask me.
Uh-oh.
Oh.
Oh,
so
what?
It's distorted. I was right, dog.
Okay.
Now you have to make a whole other explanation, Bob.
Well,
Well, I guess it both they
Charlie's
both
still
apply.
is
Yeah,
Charlie's still a fact. I don't. This is one of those I don't like their selection.
Okay.
So let's see what it says. If a receiver's noise reduction control level is increased, the idea is to make it more readable, but it makes it more readable by taking noise out, which might not be noise.
because
Well,
yeah, I was
right.
going to say because
It's
he talked about how it would make it you may not understand it as much, but you could hear it better.
But the question says, what happens as a receiver's noise reduction control level is increased? When you decrease the reduction control level, it brings it more readable. But if you increase it, things become more distorted. That's
Well,
how
I guess,
I read
so
it.
you think the
Right.
noise reduction level meter goes, the lower it is, the
well,
less you're taking out, and
This was
the,
that picture and pixel example that we were given earlier. You can focus in on it, but it comes blurry.
well, usually the noise reduction, like on the 7300, is just a button,
Hmm.
and if you the first time you press it, it turns noise reduction on. If you hold it, it'll bring up um, a menu or a little level, and they have this thing called a multi knob, which is used for a lot of these menu type things, and it'll let you select a value between 1 and 10. Now, that's not how they all work, but that's fairly typical. And as you increase the value, okay, the algorithm is going to put more noise reduction, however, it's trying to calculate what's noise and what's signal. So at a certain point, uh, it's going to wind up doing more damage than it does good.
Hmm.
And you kind of have to find that level. Typically, I run it maybe if I turn it on, I'll set it maybe 3 or 4. As you start going up, you'll hear your signal get weaker and weaker. Even though you may be eliminating a little more noise, you're also reducing the signal a lot. So
Hmm.
it's a trade-off.
no. Well, I don't like this one either.
I agree. I think we're all in agreement with that one.
Okay. What's the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier?
You want the highest outline minute? Okay, so D.
Delta.
Delta.
Delta, right. You don't want to make your plates glow uh, red. It's not good for them. In fact, they could melt. What is the purpose of delaying RF output after activating a transmitter's keying line to an external amplifier?
Charlie,
Charlie.
So and it's not only Morse code. If you do your push to talk switch,
the same
that
thing.
also activates your transmit receive relay.
So Charlie.
Yay.
What's the function of an electronic keyer?
Bravo.
Bravo.
Yeah.
Bravo.
Bravo.
Why should the ALC system be inactive when transmitting AFSK data signals? Uh, just think of FT8, one of the digital modes.
I'd say alpha.
Did you read them all?
Yeah, but it doesn't mean I understand them all. I'm gonna guess Bravo.
Well, let's see.
Yay! Because you can't use them both. You said one has to be turned on and one has to be turned off.
What do you mean?
Right. I thought you said something about if you're using the digital, you don't want the voice, which is
No,
the
if you're
ALC.
using digital, you want it. You don't want any ALC action.
Right,
You kind of
exactly.
want to try to turn it off,
Right.
but it's not a thing you can turn on or off. It depends on what your microphone gain setting is, and in the case of the digital modes, the speaker output from your computer, and those two affect how strong the signal is. And
So
that
how would
will,
you, yeah, I'm
well,
sorry.
you have to adjust your microphone gain and you have to adjust your speaker output.
Okay, so that would be how you would quote turn it off or turn it down.
Yes, right.
Okay.
And it's another one of those you kind of play with the knobs and
Because I thought you said you didn't want them both running at the same time.
both
Well, I
what?
think he's saying
The
the ALC is
AFFK
not.
or the ALC. You don't want them
You
hitting
you don't want LC operating
with the AF
when you're
as
doing digital modes.
right, exactly.
Okay.
But it's always on. You just don't want it doing anything. You have to tune it so it's not doing anything.
Right. It's always going to be
Gotcha.
trying
Gotcha.
to control the level. So if you talk too loud,
It'll pick it up
that can
and
cause it
interfere.
to come up and try to correct for it.
Gotcha. I understand.
Which of the following is a common use of the dual VFO feature on a transceiver?
I don't know what the dual FO is.
Isn't that
What?
Bravo?
So you can transmit on one and listen on the other, dual
So it
VFO.
uses the opposite sides of the band or something.
Well, it's like having two receivers.
Oh God. I
So
feel
that
like
was
I haven't
Bravo,
been
right?
listening. I haven't even been here. So let's start at the top and say, did you use a different term than this dual VFO to talk about this?
No, he
I don't
said it.
think so. I think I said it.
Hmm.
Remember we talked about split mode
Yes, I remember split mode.
and
And
the
then the
next
I'm
next
chart
sorry.
one,
and the
dual.
next chart was dual VFO. You have to have dual VFOs in order to do split mode. And it also allows you to uh, monitor a separate uh, frequency. But essentially, it's there for Charlie, so you can transmit on one frequency and listen on another frequency.
There. Yeah, I remember you saying something about being on different sides of the band or something.
Yeah. I mean, it doesn't necessarily have to be a close by frequency. It can be a different band. I don't know
Mm-hmm.
why you would do that, but you could.
Okay, so it's transmit on one and listen to on the other. Got it.
Right. What's the purpose of using a receive attenuator? Remember I talked about that control, which usually does both. You can't
Alpha.
have a preamplifier and attenuator at the same time. It's kind of either or.
Right.
Alpha.
The receiver overload for the incoming. Yeah.
Right.
Yeah, that makes sense because attenuators makes it less.
Okay.
That was a lot to take in.